Hello, everybody. It is Mr. Zavo. Today we are going to go over some order of operations. So hopefully we've been exposed to a lot of this already. I know some of you absolutely have because we've done it in class. But we're going to do a little bit of review and a little bit of practice with order of operations. This is all still part of our Learning Target 1, where you are simplifying algebraic expressions. So many of you have learned the order of operations, and you might have learned the acronym Pemdas for parentheses, exponents, multiplication, division, addition, subtraction. I like to do it a little bit different. I call it Gemdas because it's not just parentheses. It's any grouping symbol. And as you can see here, parentheses is just one of those grouping symbols. You also have brackets, but a fraction bar can also be a grouping symbol, and we'll talk about that in an example in a few minutes. Second in the order of operations, after you've simplified any algebraic or any numeric expression inside of parentheses, is to simplify any exponents. And third is multiplication or division. So this is key. A lot of people mix this up. You don't always multiply before you divide. You go from left to right. If there's a division problem before a multiplication problem, as you work from left to right, you have to do the division first. These two are kind of grouped together. And then the same goes with addition and subtraction. You perform those operations from left to right. Does not matter if subtraction comes first. Okay, so more than that when we get to a couple examples down here. First, it does matter with grouping symbols. They make a difference. So on the problem here on the left, 4 plus 6 in parentheses then raised to the power of 2 is going to give you a much different answer than 4 plus 6 to the second power. Okay? In the first part of this, you have to do the grouping symbols first. That means I'm focused entirely on what's happening inside the grouping symbols. I have to simplify whatever expression is in there first. 4 plus 6 gets me 10. Now that I've gotten just one numeric expression or one number inside, I can get rid of my grouping symbol. There's nothing to group anymore, but I can't get rid of that exponent of 2. I'm going to be working straight down as I simplify here, and now I get 10 to the second power. Remember, to the second power is a multiplication. You're multiplying the base by itself. 10 times 10 gets me 100. Okay. Big difference on the problem on the right, though. I have to look here and see no grouping symbols. The first thing in the order of operations is my exponent. And so the first thing I have to perform here is 6 to the second power. 6 to the second power is going to get me 6 times 6, or 36. I'm going to bring down the 4 plus, moving everything down vertically. 4 plus 36, I get 40. Not the same thing. Okay? These are not the same. The only difference there was that grouping symbol. Okay, so it does matter. It does make a difference. You have to pay really close attention. Detail is key in mathematics. All right, next. 4 plus 1 divided by 2 plus 3. That's what it says here. That's what it says here. The fraction bar makes a huge difference, though. It's a grouping symbol. Okay, so when we're looking at this, you have to do, whoa, we're not even going to correct that. We're going to assume that didn't happen. We have to do 4 plus 1 first. We then have to do 2 plus 3 second. And just bring down the entire fraction bar. Treat this like 3 separate problems. Simplify your numerator, simplify your denominator, then simplify your fraction. Okay, so when I simplify my numerator, 4 plus 1, I get 5. When I simplify my denominator, grab a yellow pen, 2 plus 3, I get 5. Now I simplify my fraction, 5 divided by 5, I get 1. That's not what this order is saying. This order here is not saying take 4 plus 1 and then take 2 plus 3 and then divide, because the order of operations here is telling me the first thing I have to do is take my positive 1 and divide it by 2. Well, if I take 1 divided by 2, I get 0.5. It's positive, so now I have 4 plus 0.5 plus 3. Well, that's going to give me 4.5 plus 3, which is going to give me 7.5. That's correct. Based on what is written here, that's correct. And that's why we need to spend some time this semester talking about graphing calculators and teaching you how to use your calculator. Your calculator follows the order of operations, and it does exactly what you tell it to do. If you took this problem here on the left and said 4 plus 1 divided by 2 plus 3, it's giving you 7.5 because this is what you told it. The reality is, if you wanted it to give you the accurate answer, you would have had to include parentheses here and here. If you typed that into your calculator, it's going to come back and give you a positive 1. Okay, so your calculators are going to follow the order of operations, which means you have to include it when you're typing it in. All right. All of that said, what I want you guys to do, and if you have this printed out, great. If you don't, no big deal. Copy these 3 expressions, these 3 numeric expressions, and all I want you to do here, you're not going to complete them, you don't have to solve them, you don't have to simplify them. Circle the operation that you would perform first in that. And if you're just writing this all out, maybe just write out what operation you would do first. Go ahead, press pause and try that. All right, check your answers. If you guys have questions, write something down here that you have a question, and you're welcome to just shoot an email out to us. You're welcome to, send us out something in Remind, or contact us, talk to us in our office hours, talk to us next time we're meeting in person. But subtraction comes before addition if you're working from left to right. It is not always do addition first. Grouping symbols and grouping symbols. Okay. All right, next thing I want you guys to do, again, take a look at these 3 problems. We're going to try to simplify them. Some of them are a little bit more complicated. Go ahead, take a few minutes, pause the video, write these 3 problems out, and go ahead and try them. I'm going to pause, but when we unpause, I'm going to have one done at a time. So take a minute, pause, and try them. Hopefully we get 8, so you have to do the division first, and then we bring everything else down. Then multiplication, and then bring everything down. Since positive 3 times 2 is positive 6, it becomes an addition problem, and we add. Notice I did one operation at a time here. I didn't try to do 2, 3 things at a time. And I wrote everything down vertically. I didn't get lost. That's key to organizing your mathematics, to making sure that you're not losing numbers, you're not losing terms, you're not losing parts of the expression. If you haven't finished part B, go ahead and give that a try. Before I go and finish this, I want to make sure I express, yes, I simplified this, and yes, there is a numeric expression that's just one number left inside that grouping symbol, but because the parentheses that grouping symbol are being raised to the exponent, I don't get rid of them until I apply the exponent. And that's a key important thing here, because next, when I'm doing my exponent properties, that parentheses isn't really a grouping symbol. It's just expressing what is being raised to the 2nd power there. Okay, so if I walk through this, the 12 I don't change, but I can change my 3 squared to 9. 3 to the 2nd power is going to get me 9. And I can bring down my minus 2, but I can change 4 to the 2nd power. And if it's a number next to the parentheses, that's a multiplication problem. So times 4 times 4 is 16. Okay, go ahead and finish from here. The key here is don't be afraid to use your calculator. Mr. Corney has already posted, and we posted on our Google Classroom how to access the calculators on your Chromebooks, our graphing calculators, but any calculator will work here. Don't be afraid to use them, but make sure you're using them right, and we'll have a lot more information about that when we get there. And then part C, I'm going to go ahead and make sure I just walk through some of this with you, but remember we talked about earlier, this fraction bar here is a grouping symbol. So when we see this, that's a grouping symbol. It's telling me that I technically have 2 different things that I have to do here. I have to simplify this expression 2 to the third power times 5. And separately, I have to simplify this expression, 3 to the second power minus 3 times 2. I'm going to do that completely separately. Okay? So 2 to the third power, that's 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. I get 8 times 5, which gets me 40. And 3 to the second power is 9, so I get 9 minus 3 times 2. Negative 3 times 2 is negative 6. I get 9 minus 6. 9 minus 6 is 3. But I can't just stop there and be good with that. Okay? I have to now bring all of that back down into a fraction again. This was my numerator. This was my denominator. One thing you will learn, and I would imagine everybody is going to be happy, is I'm fine with that improper fraction. And not only am I fine with it, as we get further on in our semester, it's going to be really important. So that's our quick review of order of operations. The one last thing is evaluate. So the only difference here is we have algebraic expressions. The algebraic expressions have variables, but we're telling you what those variables are up here. Key important thing, and I cannot stress this enough. When we are evaluating, we are substituting. And when we substitute, anytime I see a variable, say x in that case, or y here, I am replacing that variable and that variable alone with parentheses. I am always going to use parentheses when I evaluate. There's a set of parentheses, there's a set of parentheses, here's my set of parentheses, and everything else comes with. So that exponent goes to the parentheses now because it was with the x. And then I bring down my addition sign, then I have my parentheses, then I have a minus 12, and I gotta move these over. And I have a divided by, and then I had my parentheses for y, and those had an exponent of 2. Now and only now am I going to go and substitute. Anywhere I had an x, I'm going to put a 5. So that's going to be a 5, and that's going to be a 5. Anywhere I had a y, I'm going to put a 2. That's going to be a 2. From here, we should be able to simplify that, follow it, by using the order of operations. Little trickier in something like part B, because we already have parentheses here to the second power, divided by parentheses here. So we do the same concept. Here's an x, so I'll use the same colors. Here's an x and here's an x. Those are going to be my green parentheses. Here's a y and here's a y. Those are my blue parentheses. And now I substitute. My x's become 5s. 5 goes here and here. My y's become 2. 2's go here and here. And we simplify. Big thing about simplifying this, if you have parenthesis next to parenthesis, inside parenthesis, work from the inside out with your grouping symbols. Okay, so here I'm going to take the 5 times 2 and get 10, raise that to the second power, divided by 5 times 2 and get 10 again. Okay. 10 to the second power is 100, divided by 10, and we get 10. Okay. So take a minute and try part A, press pause and finish it. All right, our final answer becomes 27. If you need to pause to check through my work, feel free to do that. If you've got that right, flip ahead. Try 4, 5, 6, and 7. 5 are 2 of the hardest ones on here. And when I substitute, it should look like this. And this is key. Exponents apply to whatever is directly in front of it. So this exponent of 2 applies to the green parentheses, and that's this negative 3, but not this negative. So this first negative here comes down, but negative 3 to the second power is negative 3 times negative 3. That's a positive 9, but that does not get rid of this negative. Big difference from here.